All right, so today we're going to tackle something huge. I mean, literally one of the most powerful forces on our planet rivers. And, we humans, we like to be in control. So, what actually happens when we try to put a wild river on a leash? Let's dive in and find out.
So here's the big question, right? What happens when you just stop a river? It sounds simple, but the answers are anything but. When we build a dam, we're not just blocking water. We're basically rewriting the operating manual for an entire ecosystem. And those changes, they can ripple out for hundreds and hundreds of miles. So, to really get it, we have to look at what that system looked like before we ever showed up. Before we get involved, a river is this wild, incredible thing. It isn't some steady, predictable canal. No way. It's a living system, you know? It has a pulse that beats with the seasons. It swells up with rain and snowmelt, and then it gets quiet during the dry months. It runs on nature's clock, not ours. And this chart, this gives us a perfect picture of that natural pulse I'm talking about. This is the Kootenai River in Montana, way before the Livy Dam was built. Just look at that massive spike in the spring and summer, kicking off around April. That's all the rain, all the mountain snow melting, and just sending this huge surge of water downstream. You gotta understand, this annual flood, it's not a bug, it's a feature. It's a critical, essential part of the river's entire life cycle.
Okay, so if all that wild fluctuation is totally natural, why on earth would we want to tame it? Well, it's all about perspective. From a human point of view, that wildness can look an awful lot like chaos, unpredictability, and even danger. And that's where we bring in the engineers. We build these absolutely massive structures for a couple of really compelling reasons. First up, flood control. I mean, think about the Mount Morris Dam in New York. It was built for one main reason, to protect the city of Rochester from getting wiped out by floods. And the second big reason? Power. A controlled, steady flow of water is just perfect for spinning turbines and generating clean hydroelectricity. So we make a trade, right? We swap the river's wild nature for our safety and our need for energy. But that trade, it completely remakes the river. I mean, the second those dam gates close, the old river is gone. It just ceases to exist. And in its place, a new, engineered version is born. And believe me, the change is dramatic. This really shows you the difference in black and white. You see that spiky seasonal pulse we were just looking at? Gone. It's been replaced with this new reality, a flow that's been smoothed out, made way more predictable. That huge spring flood is a thing of the past, and the super low winter flow gets a boost. Now, this kind of consistency is exactly what you want if you're trying to generate a reliable stream of electricity. But it's a total rewrite of the river's basic character. And it's not just the water that gets controlled. See, a river is also a giant conveyor belt for sediment, all that silt, sand, and gravel. Before a dam, all that material travels the whole way down to the coast, building up our beaches and river deltas. But afterwards, the dam acts like a giant trap. The reservoir behind it starts filling up with all that gunk, and the river downstream is suddenly running clean, but it's a starved kind of clean. The coast just isn't getting its regular delivery of fresh sand and soil anymore. And this is where the story gets really, really interesting. Because trapping all that water and sediment, it isn't a single action with a single result. It's more like the first domino in a long, long chain of consequences, unforeseen consequences, that can literally reshape entire landscapes. Let's just walk through this chain reaction. Okay, so it starts with the dam changing the flow and trapping all that sediment, right? Then, because the coast isn't getting its supply of new sand, erosion starts to win the battle. At the very same time, with less fresh water pushing out to sea, salt water from the ocean can push its way up the river, further inland. This completely messes with the habitats for fish, and suddenly the plants and animals that count on very specific freshwater conditions, well, they can't survive. It's a cascade. One thing leads to another, to another. And that leading edge, where the fresh water is basically in a fight with the salt water, that's called the salt front. Think of the Hudson River. Normally, you've got this strong flow of fresh water that keeps that salty front pushed way downriver, out toward the Atlantic. But what happens if you put in a dam and reduce that flow? Well, the river starts to lose the tug of war. The salt water pushes further and further inland, and that is incredibly bad news for all the organisms that evolved to live in fresh water. The impact of our engineering goes way beyond living things. It's kind of mind-blowing, but we're powerful enough now to actually alter the geology of the planet, to slow down natural processes that have been happening for millennia.
And Niagara Falls is just a perfect, stunning example of this. A gigantic amount of water gets diverted from the river before it can even get to the falls. It's sent through these massive tunnels to power hydroelectric plants. So what's the result? A lot less water is actually going over the edge. And with less water, the immense erosive power that has been carving away at that rock for thousands of years has actually slowed down. We are literally changing the speed at which a waterfall eats away at the landscape. It's wild. So when you zoom all the way out, you start to realize this isn't just a story about dams. It's about a much, much larger pattern of how we manage our entire environment, from the rivers that carve through it to the very land that surrounds them. And this leads us to a really critical question. If one dam can have such a profound cascading impact on an entire watershed, what about everything else we do? What about how we manage the land itself? Because the two are so deeply connected. Well, this chart here shows you exactly how connected they are. It's pretty simple. The more plant cover you have on the land, so trees, grasses, shrubs, all of it, the less water just runs off the surface when it rains. The plants and all their roots act like a giant sponge. They soak up the water, they hold the soil in place. So when we clear that land and remove the plant cover, the runoff skyrockets, sending way more water and sediment into our rivers way faster. It just goes to show, it's all one big system. And that really brings us to the final thought for today's explainer. We have become absolute masters at re-engineering the planet to suit our needs. For flood control, for clean energy, for convenience. But every single one of those decisions comes with a price tag, often a hidden one, that's paid by the natural systems we all depend on. So the real question we have to ask ourselves is, are we getting that balance right?